the title of my presentation, AIOps and Service Management. Let us be a bit more agile. I want to invite you to a journey from a classical service management to a more or less intelligent approach. And when you speak about travel, my company would be the best choice to travel. It's the Austrian Railways. And today I will be your engine driver with about 34 years experience in IT business for the Austrian Railways. I had a lot of job roles. I started as a mainframe system programmer, went from operations management to service management. I integrated a lot of platforms and vendors. I was more than 15 years leader of the Austrian Tivoli user group, which is also part of the GSE. And I'm at the moment, and I hope more years, IBM lifetime champion. The ÖBB Group is one of Austria's leading eco-friendly companies. We transport about 460 million passengers, but not during the pandemic. We have about 150 million of tons, and we are one of the most punctual railway operators in Europe. We have 41,000 employees in railways and bus services, and we are really good company for traveling. When I start with operations management, then in Europe you speak about ITIL. It doesn't matter if you use ITIL version 2, 3, or 4. You have normally you have strategy, you have service operations, service transitions, you have problem management, event management, incident management, and all these cases. That means you have your shop. Maybe this is IBM's Blue Mix Garage. I don't know. I can't remember, but no, because it's so long that I was in Vegas where the Blue Mix Garage resided. But I saw in discussions with a lot of companies that a lot of companies have this strategy. They have a lot of assets, they have a lot of relations, they have their services, they have built their services, and they do it in their way. And when they have their services, they build their service management architecture. It's more or less stable, and it has a lot of new things you have to think of, and I will later in my presentation I will discuss these things you have to think of. This is our service management strategy or architecture. On the right hand you see that we have a lot of blue products. Blue products means these are products from IBM, but we have also products from PMC. These are these yellow colored products. We serve every operating system. We serve nearly every platform, every software. We have system monitoring, applications monitoring, end-to-end monitoring, but we bring this to our event bus, which is Netco Omnibus. And from there we go through a bidirectional interface to our impact management. The impact management is fed from the CMDP. There we have our service trees in place. The service trees are more or less automatically built from our discovery. We built more than 90% of our service trees automatically out of the discovery. We have our SLA, and I speak of about 1,600 services. And we have our ITIL disciplines with our service desk, our incident management, and a lot of groups, which I'm mentioning a bit later. With this data, to click this away. Oh, no, it doesn't work. Okay, sorry, give this a bit to the top. We have a centralized management of all the monitors. We have standardized monitors for all platforms. We have about 2,600 remote monitors, and also nearly the same amount of central monitors. We have a performance data warehouse. We have 110,000 monitoring points in total. We are monitoring on-premise and also cloud resources. We have about 30,000 events a month correlated, enriched, and calculated with Netcall Omnibus. And we have an automated event management from monitor over a trouble ticket to an SLA report. On the CMDP side, we have about 800,000 CIs in our CMDP. We built 1,600 services. We have more than 50 applications from all of the ITIL areas within the CMDP, within BMC ITSM suite. We discover more than 4,000 hosts at the moment. More of the half are virtualized. We have more than 28,000 software instances, a lot of databases, and so on. When we have our service trees, which are the basic for our service management, we have about 20,000 CIs, from which the service trees are built. We have root cause ticket, and I will show this a bit later. We have an automated service impact, and we have an automated escalation to our third level support. Third level support means we have more than 300 support teams and an automated escalation depending on daytime and trouble ticketing and reports out of this data. The SLA reports and KPIs comes from our CMDP, and we do also warehousing of the CMDP data. A bit more technical, when you take a look at our technical architecture, then it means that on the right hand, we bring data from Azure Cloud over the Netcall Omnibus firewall, also to our event management. We have our local monitoring and bring all this data to our event management. We have the end-to-end monitoring, which brings the data to our event management. And then we do that service impact management. Here's a short video of our dashboard. We built this with JSM. You see that we have an overview of data. We have service details of data. For example, here you can see that we have all the data of the systems. You can click on the service tree and you get data from it. Here are the service, the monitors, the monitoring data. When you click on the service, and we have built a service integrity, that means this is red because not all of our CIs are monitored. And you can also have detailed data. You can go from the bottom up to the service. That means you click on a machine and you get the service. I have built a management view. That means that nearly our whole environment, which are responsible for, is okay. Only one service has a problem. This is our normal behavior, how we did it in the past. This was rather fine, but our management decided that our policy, our company policy, is now cloud first. That means we have to decide if a new service should reside on the cloud or not, and cloud is preferred. I'm always wondering why this comes, because when you have the normal operations management, you build on top of the operations management your service management, and after that normally you think about cost management, and that is not so easy. But with cloud, the management gets a completely different picture. For the management, it seems that cost control is done perfectly. That means you can get the cost for every byte you use. Service management, okay. The service provider will say that service management is done. From my point of view, it's absolutely not done, because you have the same problems as you had before. And operations management is a part that should not be done, but normally you have also a lot to do within the cloud. When you go back to the picture we had before, then when this is your shop, what has changed? Not really too much, because you have new signs on your products, but you have most of the time the same problems, or you have more problems that you had in the past. But that's not the only thing you have to think about, because you get Docker, you get Kubernetes, you have VMware, which all of these products do a kind of virtualization, and this hides data from the operations team. Why? Well, what the problem is shows this short video. You have discovered your infrastructure, you think everything is clear, then you have, for example, an ASX move, and you, as the operation team, get into real troubles. What to do in this thing? You have to take care of what has switched, what is the underlying infrastructure. You have to do in other management of operations. That means you have to move from the right side, from the traditional operations, to the left side, to the more or less artificial intelligent operations, to AIOps. In our case, it's not really artificial, it's more Harris intelligent. What have we done? We have taken IBM's Agile Service Manager, which is the main part of the AIOps product, and we have filled in a lot of data. We have filled in data from the CMDP. We have filled in data from VMware. This observer name, these observers are the technology, how ASM handles this data. It's a pre-designed software interface. We fill in Kubernetes, we fill in Azure, and bring this over the event bus, over Netcall Omnibus. And the most important thing is not only to fill in the data, but to merge the data. That means merging the data and bringing on the events gives a new approach, a new view of data, and I will show you a few examples what you can do with this data. This is really interesting. Let's take the first look on my first approach when I said, okay, VMware makes a VM move. You have more than one data center, and from one point to another, you don't know where your virtual machine is running. What have we done? We filled in this data, brought the data to a map of Austria, and said our physical machines are residing in these locations. You can drill in over this map and you see, okay, This is the status of the machine. In our case, you have one machine which is red. You click on this red machine and you get the view. You see it's a software server. The software server is running on an application, and the application belongs to a service which is called video server. You can see the status. Okay, it's not the video server is not reachable, and therefore this is the root cause event. When you drill out, you can see all your data centers. For example, we have 2 data centers in Vienna. The one has 294 machines. You can click on this. It's 292. You click on this and you see, okay, one machine has a major severity, the other machines are green. That means you have not to build relationship between these machines. You see it very easily. When you click on this machine, you see the machine belongs to Cognos. This is the service, and a lot of databases are yellow. Why? You click on the machine and see, okay, there's a monitor running on this machine. When you click on the status, you see, okay, the monitor 5% free. That means the disk space is too low. You can very easily see that the resource, the outage of the disk space causes in a lot of errors on the databases. The next view will be the Cmdp view. I click on the Cmdp and say, okay, search for a service. In our case, I'm searching for our monitoring service. It's called Tivoli Monitoring at Production. I click on this and say, okay, what is the monitoring service? What components is it built of? You can click how many hops you want to make, and you see, okay, when you click on 3 hops, there are a lot of dependencies. You see the pink ones. The pink ones are dependencies from service relations, and the others are dependencies which comes from the other sources. When I say I want to see only the service tree, then I click on the service tree. I take the filters, say, okay, let's take a hierarchical view. Then I can see, okay, what's going on. This is the service. There are cluster system, databases, whatever. One machine is yellow or orange. This is our event bus, because we drive a heartbeat and say, okay, is it running or is it not running? And therefore, this major event resides on our event bus. You can click on a machine, say, okay, show me that machine. That is a lot of data which comes out from the Cmdp. I can get the neighbors. In our case, I have a server as a neighbor. This is the physical machine. I can click on the physical machine, say, okay, where's the location? Then I go back. It's in the Gegerstraße in Vienna. It shows the location. It's the topology view, same method as I used before in the first use case. I can also click on additional neighbors. For example, the neighbor is a cluster system. It's the stretched Red Hat cluster. That means more than one machine are on this Red Hat cluster. When I recenter the view and say, okay, render it with 2 hops, and show it in another view and give back all the views, all the visibility I had before, then you see that you have a lot of data only with 2 hops. And when you click on this and go a bit further away, then you see what dependencies are with 2 hops in the data center. And even if there are so many dependencies and so many icons, you can very, very easily define where a problem is because of the color. In this case, there's one machine which has a color and the color yellow, and you can find this machine even there is no dependency between these views. The other interesting thing is Kubernetes. You use the Kubernetes observer, for example, jump within the topology and say, okay, there's a service within Kubernetes. Render the neighbors. This is a neighbor which comes from the CMDP. This is the machine, the physical machine on which the computer system on which the Kubernetes servers are running. You can see where it's running. You can see a resource status. You see that the resource status comes not only from the CMDP, it comes from Kubernetes, it comes from VMware, and the resource status comes from all of these servers, from all of these observers. When I decide to have 4 hops, then I can see that within this Kubernetes environment, you have a lot of pods which are in error. You can click on these pods, or let's make it easy. I want to have host-to-host connection. On this connection. And can click on these resources. There's a warning that at least one container is restarting. There's also a warning. There's a loopback, a crash loopback. And I decide, because this is I decided to see the last change in timeline, because the ASM stores the data and you have the chance to take a look in the past and to see why are these systems crashed. And you find the problem that there's an image in a version 1.18 and there's a new image in the version 1.19. New services and the new pods are created. The old one are lost, and you can find not only with Kubernetes, also with the normal data. You can go in the past and take a look what the environment in that timestamp has done. The other thing I want to jump over is to go over the event list. It's the same procedure. Maybe interesting is the one which deals with the cloud services. I go to a subscription. In our case, it's subscription Microsoft 01. When I take 2 hops, then see, okay, there are a bit more things. And I want to focus on this managed island. We call this managed island. That means we support these islands and give also additional services on it. Make 3 hops, and then you see that you get data from the cloud. It's an infrastructure as a service. That means you get data of a cloud, which is brought together with the CMDP data and maybe VM data if it is within the service trees. And then I say, okay, I want to have a computer system, database, a service, system enabler, server, and the subscription, and all these other things from the cloud is not valuable for me. Then you take this data, click on it, and then you see the pink line. That means it resides in a service tree. But you see also that there are a lot of machines which are not in a service tree. And this is you get the status from the CMDP and the status from the cloud, and that's one of the problems, that if you have a hybrid environment or even you have a cloud environment, it's not so easy to get all the data for your service trees and to build regular service trees that you get all the data out of it as you have normally from the service trees on premise. And ASM and this AIOps environment is a good chance to discover data on the one hand from on premise, on the other hand the data over the observer, and to get more visibility how to build it together and how to get all these service trees and these impacts, and to have your normal good infrastructure in place. Okay, that was a very short overview over these things we made with AIOps. It's a really interesting product. It runs itself on a Docker environment, and it's worth to take a look at it because it delivers great performance and great visibility over your environment. Thanks for listening to me.